In the previous lesson, we learned about how definite integrals are used to find areas of regions, and there were two cases that we looked at: regions formed between a function and the x-axis, and regions formed between two functions. And these are examples of each of those two cases. And definite integrals are also used to find a certain kind of volume. We call it volume of revolution of a certain kind of solids. We also will take two cases here: solids that are generated by a region between a function and the x-axis, and a solid generated by a region between two functions when these regions are rotated around the 360 degrees or 2 pi radians around the x-axis. So this is the first case. Suppose you have this function. You have a function y equals f of x, and forming this region. So we have this region formed by the function y equals f of x from a to b. Imagine rotating this region 360 degrees or 2 pi radians around the x-axis. Then you will form a solid, which we call as a solid of revolution. And it will look like this. And to find the volume of this figure, the volume V would just be pi times the integral from a to b of f of x squared dx. This is a formula. Or you can make this formula look a little simpler if we use y instead of f of x. So that's pi from a to b of y squared dx. And for the second case, solids generated by a region between two functions like this one. We have here the function y equals f of x, and this is the second function is y equals g of x, and we have this region. Now imagine rotating this figure 2 pi radians around the x-axis. This is the figure that will be formed. And to find the volume of this figure, we are going to need to distinguish between the upper functions. In this case, f of x is the upper function and g of x is the lower function. And to get the volume, so the volume V will be pi times the integral from a to b of the upper function f of x squared minus g of x squared dx. Now let's take some examples. Let's have this first one. Use integration to find the volume of the solid generated when the line y equals x for x from 1 to 4 is revolved through 2 pi radians around the x-axis. So let's make a quick sketch. This is y, this is x, and let's say that this is the line y is equal to x. So if we revolve this 360 degrees around the x-axis, figure formed from 1 to 4. So let's say this is 1 and this is 4. So the figure formed will be, it's a figure formed. Again, this is Nice picture of the diagram. So what we do to find the volume will just be V equals pi times the integral from 1 to 4 of y squared dx. Now because y is equal to x, it will just be 1 to 4 of x squared dx. And this could be easily evaluated by hand, but whether you use your calculator or do this by hand, you should get 21 pi. If you use it by hand, you get 21 pi cubic units. This is about, if you use your calculator, you'll get about 66.0 in 3 significant figures. Let's have another example of one arch of y equals sine x is rotated through 360 degrees about the x-axis. Now notice that in this problem we are not given the lower bound and the upper bound. So unlike the first problem where we were given the lower bound and the upper bound, this one does not have. And that is because one arch of the curve y is equal to sine x is this, and so this is the region formed. This is the region formed, and so right away we could see that our lower bound is 0 and our upper bound is pi. So to look for the volume here, volume V will just be pi times the integral from 0 to pi of sine x squared, or you could write that as sine squared x, and that's dx. I'm going to take this. So again, this is just sine squared x. So again, this is a function that could easily be done by hand. We did this function. We found the integral of this function before. Now, whether you do it by hand or you evaluate this by hand or you use your calculator, you should get, if you evaluate this by hand, you will get pi squared over 2 units cubed. Or if you use your calculator, this will give you about 4.93 units cubed. Okay, let's take an example of case 2, where you have a region formed by 2 functions. So over here, you have a part of the graph of y is equal to x squared. This is actually our lower function. So this is your y sub L. And the graph of y is equal to square root of x, this one. And this is our upper function in this case. And if this region between them is rotated 2 pi radians about the x-axis, the figure that will be formed. So this is the figure that will be formed. And to find the volume of this figure, it's just pi times the integral from 0 to 1, because we have here, this is 1, of the upper function, which is, this is the upper function. So the formula is y sub u squared minus y sub L, the lower function, squared dx. So in this case, as I pointed out earlier, the upper function is square root of x, so we will square that, minus the lower function is x squared, that's x squared squared dx. And again, the functions are simple, so this could be easily done by hand, and you will get 3 pi over 10 units cubed. And if you used your calculator for this, you will get about 0.942 units cubed.